Yo, what's up, everyone? Um, so this is the second problem set for this week. Remember that this is the first problem set week of the second semester. And today is Wednesday, January 13th. So I think a lot of you are like worrying and figuring out the old stuff, and that's fine. But we are continuing. And the good thing about this problem set is that it's all review. Since 2021, we've started a new set of lessons called sequences, and it's completely new from the stuff we've been doing before. We are going to tie it back, and it's going to be good. But I decided that this worksheet, we're going to slow it down, and I'm just going to talk about stuff we did before. So if you feel really good about this, just work on it on your own and just check the answer key. But if you're trying to do well the second semester, like now is the time to set the wheels in motion, I guess. Okay, good. So I'm going to try to do this relatively quickly. I don't want it to be too long a worksheet, but we have 4 different types of questions we're looking at. And we know that it's all about sequences. And a sequence is just a set of numbers in a row, right, with a comma. So here we have this sequence, negative 19, comma 2, comma 23, etc. And it's asking us to do 4 things with that. So we have 4 different things we have to look for. And the first thing is just identify the common difference between the terms and the first term. So we know that we're going to use an equation, and I'll give you the equations again today. But we know that the equation for the general term, so if we want to find any term in my sequence, all I have to do is find the first term and the common difference, and n will be like the variable in that equation. Whatever n we plug in is the value that we're looking for. So here, the easiest thing to do is just name the first term first. Nothing complicated about that. Negative 19 is the first term. And then D is the common difference. Now there's 2 types of sequences, arithmetic and geometric. And we're kind of ignoring geometric right now and doing just arithmetic, so that makes it easier. The common difference is just how much you're adding and subtracting to go from number to number, okay? And this first number is negative going to a positive, and that might be hard, but you can even ignore that if it helps you just to think, what's the difference between all these numbers? Because it has to be the same, right? You go plus 21. And if you are unconfident, you can use your calculator a ton in this unit, and it becomes very obvious. So if you're like, I think the common difference is 21, all you'd have to do is start with your first number, negative 19, and add 21. It's 2, so that's correct. And you could just keep going to confirm that that's what the difference is. So the difference is 21, and we're going to use those 2 numbers in my equation, which I'll always give you, which is that the general term, any term in my sequence, can be found by taking the first term and then adding. Yeah, they're doing construction next door. That's kind of hilarious. I hope it doesn't affect it too much, because they said it was going to go on for like 2 months. I wonder if you guys can hear it anyway. Okay. But yeah, all you do is you take the first term and then you add the common difference and then n minus 1. You keep n in the equation, okay? Because what this equation does is you plug in any n, and that solves for that term. So if you put 5 here, this equation would give you 65, okay? This is the general term, but we want to put it in the simplified form as well. So know that if you want to simplify this, that means just get rid of the parenthesis by distributing, and then it becomes kind of obvious. So negative 19, all I'm saying is multiply 21 to n, and then 21 to negative 1. And then from there, combine your like terms, okay? 21n is going to be the start of my equation, but then negative 19 minus 21 is going to give you the second part. So I'll circle both of those. They're both valid equations, but this one's a little easier because it's smaller. Okay, so know that this is the simplified form. From here, it looks like we've already done a lot, and the next 2 aren't that bad. It says we want to write the sigma notation for the sequence and find the sum. Now, the big idea is that the sum is just you add up all the numbers, which is pretty easy, but you want to write a notation or a terminology that expresses the sum of numbers. And I know I said that really bad, but if you see this sign, the E kind of sign, that stands for sigma, which stands for the sum of all of those numbers. Okay, so we just want to say in math words the sum of this sequence. So this sequence is 21n minus 40. Okay, that's the equation for the sequence. And we want to find the sum of the sequence from the first term to the seventh term. So we write n equals 1 and then 7 on the top. What this stands for is what's the sum of the first 7 terms of this sequence. Okay, so that's the third notation. These are the big 3 notations that you need to be comfortable with. And then the sum is just adding them all up. And we have an equation that we're going to use, but in my opinion, if it's a small sequence, anything less than 10, you can just do it like this, where I'm literally just adding them up on my calculator and getting 308, right? Some things are simple. Sometimes there are like really simple shortcuts. So the sum of the sequence is 308. Okay, that's how you do that whole first one. For the sake of time, I'm just going to move on now. And we're going to go back to sigma notation at the end to kind of clarify that more. But what this question's all about is writing the sequence given information. So think that this actually isn't so bad. Think that we took the sequence and found the information last time, but this time we have the information, we have to find the sequence first. So it says write the first 5 terms of the sequence. And if you're given the first term, this is extremely easy. Okay, let me show you. So the first term is negative 11, and then the common difference is negative 3. And that means the number is getting less and less by 3. It's going down by 3, right? The common difference here was 21, so we kept adding 21. If the common difference is negative 3, that means we're going to subtract 3 every single time. So those become the numbers. Really straightforward. Then it also just asks us to create the equation. But remember, all we need for the equation is these 2 numbers anyway. So if you're given the first term, everything you have to do is super easy. So let me just plug those 2 into the equation. Negative 11 plus, but we'll say minus 3 and minus 1. So that's the general formula. But if we want the simplified formula, let's distribute the negative 3 to both of these numbers. So un equals negative 11 minus 3n plus 3. Simplify that to un negative 3n minus 8. Now, we're going to do 4 in this set because it is different if we don't get the first term. Okay, so in this case, we have the 15th term of the sequence is 25, and the common difference is 2. So the big question is, how can we find this equation and find these terms without the first one, right? We can't just say the first term is 25 because it's not. One way you could do it is you could write the 25th term and then, or the 15th term and then keep going down. So 15 is 25, 23, 21, 19, 17, etc. So you could cheat the system that way, but I think that's really tedious. So what we're going to do instead is use these 2 pieces of information in my equation. Okay, so let me write the equation first. And I think this is the hardest thing by far in the whole set. We know we want this equation and then to get in the simplified form, but we don't have the first term. However, U15 is going to be something that we can plug in here as long as we put 15 in for n. Okay, so remember that all we're doing is saying that this equation can tell you any term in your sequence based on the first term and the common difference if you plug in which term it is. So if I want to know what is the 25th term of my sequence, what is the 15th term of my sequence? Okay, wait, let me just say that again. If I know the 25th term, no, I keep messing up. If I know the 15th term of my sequence is 25, We don't know the first one, so we're going to try to solve for that. But we're talking about the 15th term, so we can plug 15 in for n here. Remember that anytime you have an equation with variables, you can solve it as long as there's only one variable left. So what I did here was we're trying to solve for the first term so that I can write it out and put it in my equation by using the 15th term. The 15th term is 25 and n equals 15, and we're going to solve for this. So this is 14 times 2, so 28. So 25 equals u1 plus 28. And then if we want to solve it, I'm just going to bring the 28 to the other side. So again, I think this is the hardest one. But once you get there, it's pretty satisfying. The first term is -3. Okay, so now I can actually write all my terms, my first 5. By adding 2 each way. So those are the first 5 terms. And now if I actually just want to write the equation un, because it's anything, any term we can solve, equals -3 plus 2 n minus 1. And then if I want to simplify that, I'm going to distribute. And I know I said this quick, but it is review, and I'm hoping that we feel like we're in a pretty good place with this. So there's that, and then it's just going to be un equals 2n minus 5. So again, this is easy if you know the first term. If you don't know the first term, solve for the first term. Okay, very nice. I think we're over halfway done at this point. Now we're going to talk about it in sigma notation. And I'm only going to do one of them, so I'm going to choose to do this one, the 6th one, number 6. All it says is to write out the terms of the sequence and find its sum. So this is another way to write out the sequence, another hint or clues to write out the actual numbers. You either start with the numbers or you start with clues, okay? That's the big thing to think. And here, the clue that we have is that this is our sequence, and we know that there's 10 terms to it. And if it's in sigma notation, it's actually really easy. Okay, all you have to do is plug 1 into the equation to find the first term. We know that that's what this equation is all about. Find any term in your sequence by plugging in that number. So here, if I want to find the first term, all I'm going to do is plug in 1, which is going to be -18. So the first term of my sequence is -18. Now, I have to be able to read this. If I'm reading this, whatever's connected to n is the common difference, right? When we plug it in, it's undistributed, but it's always going to be connected to n. I think I'm talking a little fast today, but I'm not that worried because it's review. If we know the common difference is -10 and the first term is -18, all I have to do is keep going down by 10 for 10 terms. Okay, so when you're reading this, the top tells you how many terms you're trying to find. So we need 10 terms. And then it asks us to find the sum. So that's our sequence. And if you see it in sigma notation, this is implying that you need to find the sum. We want to know what is the sum of these first 10 terms. Now, 10 is on the cutoff, in my opinion. For the next question, we're going to use the formula, which you can always use. But if you think that it's easier to just add them up on your calculator, that does work. So I did this example to show you that you could do this. And that's going to give you the sum as -630. But it was a lot on the calculator. And sometimes you could get way, way, way more terms. And that's where we want to use the sum formula. So let's do it. We're going to do number 7 and then number 8 you can do on your own. All we have to do is the exact same thing we did before. Write out the first 5 terms and then find the sequence, the sum of the sequence. Okay, so this sequence has 25 terms, but it's only asking us to write out the first 5. because it would be kind of ridiculous to write out 25 terms, right? So all we're doing to start is we want to find the first 5 terms of the sequence. We're going to plug in 1 here. So it's just 1 minus 80, which is equal to negative 79. So the first term is negative 79. And we can identify the common difference here as 1 because there's no number connected to n. So if the common difference is 1, that means the number is getting 1 greater every single time. So that's going to be my sequence. Now, here's the big thing. Here's the last thing. It's asking us to find the sum of the 25 terms. And I'm not even asking you to write them out. Think that it's 70 plus 70 plus 70. It's a ton of them in a row. It would take forever to do. But that's why we have the sum of an arithmetic series formula. So let me write it in, and we'll talk about how it's really easy. All we have to do is find the first term of the sequence, which was negative 78. Wow, I messed up. That should be negative 79. These are the first. I don't know why I did that, but yeah. The first term is negative 79, and I need to find the last term of the sequence. The last term isn't negative 75. It's the 25th term of the sequence, okay? So I need to plug in the 25th term, the first term, and then 25 divided by 2, and that's going to give us everything we need. So we know that there's 25 terms. The first term is negative 79, but we don't know the 25th term, okay? So what makes this method harder is you have to identify that term, the 25th term of the sequence. But we have the equation, okay? It's going to be pretty easy. N equals 25. So it's just 25 minus 80. So in this case, minus 55. That'd be harder if this equation was longer, and it makes it pretty easy in this case. But hopefully you understand the logic. The 25th term is 25 minus 80, or negative 55. So I have the first term, the 25th term, I add them up, and then multiply them by 12.5. And that's going to give me the whole sum. So we're getting a huge number. And that's why we use the equation in the first place, to save us the time of adding them all up. Alrighty, so that's that. If you are still finding this really hard, take your time with the practice yourself, and I appreciate you.